So, hi all, this is going to be our day 11 for Google Cloud Fundamentals training. The topic that we are going to discuss today, which is going to be even extended, not only this service but beyond that, but for today we have planned this. So the topics that we are going to cover today are Google Cloud networking services, networking services overview, the different types of network that we create on GCP. Then we are going to talk about the virtual private cloud network, okay, the VPC itself, and different flavors or different versions of VPC. First, we are going to look at the architecture of standalone VPC, and later the shared VPC, which is a specialized service that is provided on GCP. Uh, I believe probably it is not available on any other platform. Okay, okay. So let's get started. Right. So, as we want to understand on high level how the networking, what is networking, how it look like on the Google Cloud platform, right? So there, this is a typical graphical representation of the Google Cloud services, networking services. Now let's touch base each of these components one by one, and we will revolve around some specific questions if you come up with, and we'll try to resolve that, right? So there are going to be a lot many components here which may not make sense immediately. So let's be a little slow also here while we are trying to understand the networking concept overall and how it works on Google Cloud Platform. Okay, fine. So let me share a different screen. Let me know if all of these components are visible to you. Give me a second. Yes. So is it visual to you all? Just give a thumbs up. Okay. Thanks, Raju, for confirming it. Okay. So now let's look at from the user perspective. I mean, whenever a user tries to access the network on Google Cloud Platform, so how does it work, right? So on the very first component, if you see, we have the users here. We can have multiple users trying to, or the developers trying to access the resources on GCP platform. So where are the resources created? Anyone can respond. So where do we create the resources in the Google Cloud Platform? Like when we talk from the organization, folder, and project level, so where do we create the resources?
In project, inside the project.
Right. Yes. So we create the resources within the project. Now, when we talk from the networking side, what we ideally mean is like the network should allow me to access the resources which is created within the project. Okay, or it can be some managed services which can be present not only the project but within the Google Cloud's VPC itself. Okay, fine. So now here we got an user who is having the access to internet. It will try to access the domain or the URL of GCP, Google Cloud. Okay, and it is going to hit to the load balancer of GCP. For now, just park it here. So we are talking about the load balancing on GCP platform. Okay, so whenever there is going to be a URL like www.google.com, okay, so that's a URL. Now, whenever a user is going to hit or enter that URL on the browser, it is going to the backend where it will check where the I mean how the access is given to the user. So it is going to identify from which location the request is coming, right? Now, if I'm trying to access it from India location, it is going to send the request to the load balancer which is created for the India location. Okay, because that is where it is going to provide me access immediately, quickly. If I try to access some of the resources which is actually present in US location, there will be some sort of delay in response. There can be some sort of latency with it, right? Okay, so here, if you see, it will try to hit the HTTP load balancer, which is a front end load balancer, right? Now that is going to check whether this particular resource or the request Like suppose I want to download some of the PDF data from this site like google.com, right? So in that, if I have some resources which is present in its site hosted where they have the PDF files present, or maybe some images, or maybe some video files, right? If that is available on their CDN, cloud CDN is, what is that? Content delivery network. Okay, so this is like a caching for any of the files, any of the data. Okay, so if it is going to be a static one, or if it is going to be a frequently accessed data, so what they do is they keep using with the help of cloud. Okay, so that service is going to cache the data at their global edge. Okay, so just make note of all of these components, the keywords, which is going to be a foundation of understanding the overall network. Okay, now as I said, this is giving me a content delivery and performance at the global edge. Okay, so they are actually installed or enabled at the edge of the network. So edge is nothing but whenever let me open a new tab on the browser. Give me a second. Let me just open the edge location understanding also we can have there. Give me a second. Okay. So if you see this new tab, did it appear? Okay. Yeah. So here, if you remember, I was showcasing you the regions and uh, uh, the zones and the overall VPC, right? There we were also talking about different edge locations as well. Okay, so here if you see, we have suppose one region like North America is one region. Okay, within that I can have multiples of edge locations, like it's not not, you can say, altogether a zone or region, but it is only giving you an option to extend your regions or the zonal facilities, so that you can keep some data there, and you don't want to create a separate network for it. I mean, it's like availing your data to the nearest of the where the population resides, right? So suppose if I am trying to access some of the data from India location. Okay, now let's see if we have something from Asia Pacific. So you can see we have edge locations in Chennai and even in Delhi, right? But there is no region as such in Chennai location, right? It's an edge location here. So they are helping us to perform better whenever we want to cache some data over the network. Okay, so let me go back to this particular page. Okay, so here it is talking about the cloud CDN, which enables it performing better over the content delivery, right? So I want to cache some data so that it can be streamed faster. Okay, so whenever a user is going to try to access some data, some resources, it is not going to check inside this backend and then get all of those information all the time. It will cache it temporarily here and deliver it. If there is some update to this cache data, then only it is going to check behind the in the backend and retrieve it again and save it again on the cloud CDN temporarily, right? Okay, so that is from the cloud CDN aspect. Now next is like there is a new keyword, cloud armor. Okay, so if you try to relate it with the keyword armor, right, kind of a protection, kind of a shield, right? So cloud armor is a kind of a similar component here, similar service here. What it does is it tries to see if there are any kind of attack happening on whenever there is a API request or the request is happening from the user or the external world. If someone is trying to hack your system, if they are trying to put a lot many requests continuously, right, to shut down the backend, okay, because if there is going to be a lot of node continuously, then obviously it may impact the performance, right? So Cloud Armor is a service which scans for any of the threats, okay, at the layer 3 to 7, and at the geo level it is a, you can say, web application firewall. Okay, so whatever web applications, the front end applications are running, it acts as a firewall for them. We saw that how the firewall works, right? We had enable, I mean, it's kind of traffic which tries to stop or denies of some of the accesses to some resources, right, which was very much for the backend, if you remember from the previous session. So firewall rules that we had set up during the previous session from the security stuff, that was for the backend. Now armor is actually running on the front end. So whenever a resource is being accessed through the URLs, Cloud Armor is going to verify that. Okay, so it will act as a web application firewall. Okay, and then it is going to provide a defense for this application. Okay, denial of service. DDoS is a denial of service defense. Like if it finds that okay, this is not a valid or the verified request. Okay, it is something that it is impacting the overall processes. I'm going to deny the service. I'm not going to respond to this request, and that is the work of Cloud Armor. There are some enhancements already done with the Cloud Armor, which helps in identifying any anomalies. We can even block some of the requests if it is coming from a specific region, a specific country, or maybe based on a specific IP address, which we find that okay. So I just want to highlight here that recently, like over the weekly sessions that I used to do the open call, right? So in that we were actually discussing that okay, so this Cloud Armor has an option to actually disable access to specific IP addresses, but also it can actually, I mean, we can provide a list of IP addresses, like these IP addresses are identified by the global security organizations, right? I mean, the internet security organizations. So they will provide a list of IP addresses which are probably going to be much of coming from dark web or from the hackers. So we use even that also as a primary, I mean, the preventive measure to avoid access to those IP addresses, which keeps on updating, right? So that's a work of Cloud Armor. So here again, there is another service, or you can combine these two. So we talked about Cloud Armor. Okay. We also want to see if the user, this user, what we are talking about, the user like the I mean, it's authenticated or unauthenticated user, or maybe the developer, whoever is actually trying to access the resources here. We want to see if it, I mean, it is already known to the environment. Like, is it from the existing user, or if we have already authenticated this person earlier and we know about it, right? So we want to identify that, and for that we combine the Cloud Armor along with Cloud IAP, identity aware proxy. Okay, this is kind of a proxy server which will retrieve, I mean, try to filter out if the user who is trying to access these services, okay, if that is already known by this Google Cloud platform, like if it is already added to the cloud identity, if it has any permissions already identified or added with the help of Cloud IAM, if that is already done, then I'm going to allow this user access and serve its request. Okay, so combining these two components are going to make your network access even secure, or the resource access to the resources even better secure, right? So if that is clear to you, now let me take a pause and get some questions if you have any. on any of these services that we talked so far? Is it going fine so far? Are you able to relate it? Anyone can respond?
Is it good till now?
Okay. Okay. Fine. So definitely we can go a little deeper if there is a requirement. For now, just try to understand Cloud CDN is for content delivery network. It is caching the information. HTTP load balancer is to load balance whatever request is coming and try to divert it to the location nearest to the user to to help in reducing the latency of response, okay, or avoiding any delay in response. Cloud Armor is a production layer, so web application firewall, it acts like that, okay. And then Cloud IAP is identity aware proxy, which again helps in authenticating the user and validating the user, okay, based on the context, like uh, uh, whether the user is actually created to, I mean, the user only should have access to the dev environment or production environment, maybe staging. So based on that, because it is going to check it behind the scene. Like Raju, if you remember, when you had created a firewall rule, like in the previous lab that we did,
Yes.
so when you try to access your compute engine instance, okay, so
Yes.
initially it denied, and then later it started trying to access it through the cloud. I mean the IAP, the cloud identity aware proxy. It was trying to access. Even with that, also it did not work because we had denied the permission using the firewall, right? So by default, it is going to check for the IAP if nothing else works. Okay, you can give it a try next time also whenever you work with it. One more
Okay.
update from the Cloud Armor. So Google had, I mean, recently, I mean, I think almost 6+ months back, they had published a report saying that Cloud Armor had stopped a DDoS attack, denial of service attack, uh, which was the highest by any of the service providers. Okay, I think it was around 14 Tbps or I mean, I don't have the number. Maybe we can check that later. But that was the highest denial of service attack that was stopped or or served, or you can say it was stopped by this Google Cloud. Okay, because of the network that they have, the global network, the availability they are able to manage, the number of resources they had created behind the scenes, so that the request that was coming, they were able to handle it. So this was very huge. I mean, it was a lot much in the news also. Okay, we can have a look there. Okay, now let's talk from the network tier. Okay, so networking tier, if I say here, so we will see there are two types of networking tier. Okay, standard and the premium tier. Obviously, they will have their own advantages and disadvantages. The number of services that you are able to access, the way it works. So that is going to differ. Like we will be seeing that if it is covered as part of this architecture. Otherwise, you can just try to relate it. Like so, whenever we have a standard network, okay. So the request, whenever you are I mean trying to access any resource from internet, like you have your router at your home from which the network, I mean it is going to allow you internet access. Now it is going to go through a different multiple hops, multiple servers, after which it is reaching to the request. I mean suppose I want to access some resources in US. Okay, so the number of hops, number of steps that it is going to take to reach to that resource and return back, it is going to be multiples, like around 10 to 15 hops. Okay, in case of standard tier. Okay, just trying to give you an example for what is a major difference you can see. Now when I talk from the, because it is a regional kind of service they provide with the help of a standard tier. Now in case of a premium tier, the performance will be better. Okay, because now here you are actually getting the global service. Okay, so in that case it is directly going to jump to the service. I mean maybe 2 or 3 steps only, like from your the the router that you have at your home, and from there to the direct to the another router which is present in the US region, and from there to the service which you are requesting and then revert back. So number of hops or number of steps that it is going to take for the premium one, it is hardly around 3 to 6. In case of the standard tier, it is going to be more than 10 plus hops, which delays the response that you are getting, right? Okay. So that is majorly a difference. Let me also showcase that same, because that it will not make sense if I just talk about the different tiers. So I'll just quickly show how the tiers look, or what tiers we have created in our console. So give me a second, it's just loading. Okay, so let's right. So now let it appear first. So now if you see here, this is the console that we have, right, in our project. I will go to the networking VPC network. Okay. Fine. So now if you see, this is our VPC network. Let's see which tier it is created. Okay. Okay. Can you see it now? If it is, if we have it somewhere. That it's, or I can call premier. Let's see.
Voice is breaking, Jitendra.
Is it okay? Okay. I hope I'm audible now. Sorry for the network delays.
Yes, it is fine.
Right. Yeah, I was showing that this particular network, whenever we create, so we do see that there is a regional or the I mean the standard or the premium one. Okay. For now, I'm not able to showcase this by. Okay, no problem. But okay, it should be here somewhere. Okay, let's not wait a lot on here. Probably if I could have shown you, but it's taking a little time. Even I could have covered that part. Okay. Anyway, so the difference that I have discussed, like you will have the multiple hops, so the the rate at which you are getting the request served, that is going to be more in case of standard one, and in premium you will be getting a better. So that's what it says. You get a better performance for premium tier, and it is more cost effective when you are using a standard tier. For enterprises already, obviously we are going to use the premium tiers. Okay, so these are the two tiers that we see. Okay, then there is a word, network interface card, NIC. So this NIC we mostly see with the compute engine instances. Okay, when we attached a compute engine instance, and in that we will have the NICs created, which helps in creating multiple network card for us. Like I can use the same compute system, okay, and I can have a multiple ways to connect multiple networks to it. So even there also we have this concept of, I will cover NIC for sure here. Let me just see if the network working fine. Okay, it's still a little slow. Okay, no issues. Fine, whatever concept is being shown here because of the network issue, we'll keep that ready for the next session also and try to come back. Okay, but NICs are helping us to give multiple interfaces for connecting to different networks. Like if you have tried to observe it, you can connect to the multiple Wi-Fi's if you have multiple of networks created with it. Like you can have this NICs created like around 8 you can create with GCP also for each of the project, and that's how it works. Okay, but we'll try to cover it more. I mean, even I am not satisfied with the response I'm giving you here, so we'll try to cover it more. This is not that immediate requirement to understand on the fundamental side. It is more of if you are going more into the network specification. Okay, okay. So if that is clear, let's go a little deeper and understand the different ways of creating the networks in GCP platform. Okay. Now, if you are able to see these two architecture, one is for project host VPC, I mean the prod, and there is a dev host project. Okay. We'll take one example here. So we'll go with prod VPC, and then later we'll go deeper into the shared VPC and what. Yeah. So let's see. I think now the network should be fine. So I was talking about the prod shared VPC here. Okay. Instead of going deeper into the shared VPC concept as of now, because we have that in the next slides. So for now, let's understand what is a VPC. Okay. And then we'll discuss from the standalone as well as the the shared VPC as well. Okay. Yeah. So let me move to the next window. Yes. Okay. So if you can see the standalone VPC here, the slide that I'm sharing now. So we have okay. So we can see that we have a standalone project. You know where the project is created? Within the organization, you will have the folder, and within that we will have a project. Okay. It's a standalone project. It is not attached with anything, nothing else. Just a project. Okay. Now, whenever we create a network, it will be part of a project. Fine. So this VPC network is created within a project. Like you have seen in this screenshot as well. I mean, in the browser as well. Now, if I try to load it, for some reason the network is creating a concern here, though we are going through the networking itself. Okay, let's see. So if you see, this is my project GCP demo 028, right? And the network is created within this project. If you can understand that now better. So I have my VPC network created within this particular project, VPC demo 028. Okay, I mean GCP demo 028. Now that is about the where we create the network. Now let's move forward from there. So if that is clear to you, like we are creating the network within a project. Now in the project you will have the regions, right? I mean, within the network we will be creating a region, and within the region we will be creating a net. Okay, so now relate it like we got a VPC. In case of GCP, at the very initial stage where we started the sessions, we talked about how the VPC looks like. It's a global service, right? So the VPC is created on a global level. Okay, now I will take you back to this particular network that we created. It's a global network. So this VPC network is a global network, right? And within that, we will have multiple regions. Now let it load first, and then we'll see here. Right. Now if you see, we got this default, the network name is default, okay? And these are the different regions, multiple regions, which is 39 as of now. Currently we have 39 regions throughout a globe for GCP. Okay, now within this region I am going to have my subnets. This is my subnet. The internal IP ranges are my subnet range. You can try to relate the same in this architecture as well, right? So we got the VPC network, a global VPC network. Then I have a region, US West 1 region, and within that region I will be creating a subnet. Okay, now this subnet will have a range. The range is what? So that also we are going to learn today itself. Okay, so these subnets are going to be having a range, which is like here in this case /24. Okay, the least number can be /32. That is like just one IP address. Okay, and it is like increasing exponentially. Okay, whenever you are going to decide what should be the IP range for what I'm going to use for creating my network, because creating a network is a big challenge, and that is very much a important concept to understand whenever you are going to work with the cloud, because it works only because you have a right network in place. Okay, so if you have got this understanding how the VPC networks are created, what is in region, and what are the subnets. Okay, now within that subnet I am going to have an instance created. That instance will only have one IP address attached to it, right? Do you remember that whenever you created a compute engine instance, you saw a public or IP and the internal IPs?
Yes,
right?
we know.
Okay. Now, which one is going to be the IP address here. I mean the public one or the internal IP, which is going to be this VPC IP.
That will be the internal IP.
Right. Okay. Just be very clear. Everyone be very clear with this concept. Whenever we are talking about VPC networks, okay, this is a internal IP network that we are talking about. This is the internal network that we are creating. Now, the public IPs is a different concept altogether. They are not part of the VPC. Okay, they are provided by external vendors. Here it is going to be the internal VPCs. So far, if you are with me, if you got this clarity, this is how the network look like. We have the global VPC where we will have a lot many networks that we can create. Like you have seen that we have 0.0.0.0 for /0, right? So you can have complete network list, okay, that you can take and you can use to create your networks. Okay. Now in this scenario, we are going to take a chunk of it. Okay. So I'm not taking the complete space for creating my VPC. It do not work that way also whenever we create it. So there are a set of calculations, set of services, set of defined parameters which will decide you, okay, you can create your internal IPs within these range only. Okay, not beyond it anytime. Okay. So on very high level, first try to understand or get this clarity. This is how the VPC networks are created. So I will have the network and the subnet is a part of the network. It is not, I mean, external to it, but it is part of the network. So here, if I have taken 10.0.1.0 /24, now the second subnet that I'm going to create will be not 10.0 because that is already being used. So I will have 10.10 or maybe I can have 10.20. Okay, or I can have 10.30 depending on what this is allowing me to do. So here I am using 24. So I need to make a calculation also there how it works. But for now, just understand whatever is left after we have created this particular subnet, only that space is available here for me to create another subnet. I cannot have a overlapping networks. Okay, the IP ranges cannot overlap within a network. Okay, is that clear?
Didn't get that one, Jitendra. Can you repeat it again?
What I'm saying, this range whatever I have created, right?
Okay. 1.0. Okay. /24. Okay.
Right. So
Okay.
I can keep on creating the network. So we understand we have only the 8 bits per
Yes.
uh, 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 part of this IP ranges whenever we are creating, right?
Correct. Correct.
Okay. Now let's go. Okay. So I don't want to confuse you all. So for now, let's limit it a bit. We'll try to explore it better in the next session also. For now, just take it that we cannot overlap the IP ranges. Okay. The subnets are part of the global network, the VPC global network. Okay. For each region, by default, if whenever we are creating a network, okay, so if we are going to let Google of creating the network for me, which is called, which is also called auto network, auto mode of creating the network, right? You can see here subnet mode, subnet creation mode is auto subnet, right? There are two ways of creating the network. So the auto subnets are going to create a default subnets for each of the specific regions. Okay. So if suppose we have this US Central 1, okay, so it is going to create a subnet with this range as a default, right? But if we want to actually let create a network with maybe my own way of creating it, then I can actually delete it, which is very much a procedure that we follow. We don't use any default networks when we work in an organization. We create our own networks. Okay, we don't use a default, the automatic creation of it. We create a custom network. Okay, there are two ways of creating these networks. One is a auto mode, and another one is a custom. Okay, now you can change your custom network to the auto network, but auto networks cannot be changed back to the custom one. This is another concept. These two things please remember. So auto subnets can be created, auto networks can be created by default by Google Cloud itself, which is not a preferred way of doing it. We create our own network, a custom network, which can be later changed to the auto mode if we want, which again, that is also not a good practice. But there is a way to make it a auto mode. But the auto mode networks, whenever we created this, it cannot be changed to the custom one. We cannot customize it now. Okay, that is another concept. All of these networks or the subnets are part of the main network, which is here in this case is a default, right? So these subnets are going to be part of this default network. The subnets are part of the default network. Okay. Now, so far, if you have got this understanding, got this particular picture that this, I mean, this architecture, what we were discussing. So far, if you have understood how these networks are created, okay, so this is how the standalone project network look like. Okay, I have one project. Within that, I want to create resources and I want to allow access or enable networking for it, because if there is no network, I cannot create any resources or I cannot access those resources, right? So I do need a address, a network for any of the components to be accessible, right? So this is part of a standalone, just a network within a project. Okay, but there is a limitation. You cannot, I mean, whenever you are working for any organization, you cannot be keep on creating a single network for individual projects. Whenever we work in a larger organization, we will be having like hundreds and sometimes thousand plus projects created, depending on the size of the organization or the kind of project, the use case that you are working on. So the number of projects may vary. Okay, so for that we should be having some other way of maybe sharing those networks. Like I have one network created here, okay, which is very much limited to just one particular project. What if there was a way I could create this particular network within this project, okay, and let it share with other project also. Okay, so in other project I'm not going to create a new network, I will be using this network itself, right? So in this case, what Google has come up with, they have come up with a concept called the shared VPC, sharing your VPC, right? Sharing your virtual private cloud network with the other project. Now let's see that concept. Okay, so let me move to the next slide, right? So this is for the shared VPC concept. Let's understand this now. That is again a very, very interesting topic and very important topic to be clear with. Okay. So now, as I gave you some overview, what is a shared VPC? So it is like you have created a network within a project. Now you are going to use the same network to share with other project also, because the number of IP ranges that you will have, that is a lot, and you obviously have an opportunity to share it with the other network, other project also. Okay, it also gives you a better control over the networking. Like the other project, whoever is going to use it for their uses, okay, for the connectivity or other sort of things, they don't have to I mean, look into how the networking is working for their project, right? It is being centrally managed by someone who has access to this particular project where these networks are created, that the host network. So whenever we are discussing, let me know if this particular architecture is visible or clear to you. Is it clear?
Yes, Jitendra.
Okay. So now if you see, we have two different projects here, right? We have a service project A and service project B. So these are the service project, and there is another project called host project. Okay. So host project is the one who is going to have the network created, and it is going to share it with the service project. The service project is not going to create its network. It is only just a project, but it wants to use or have access to the network on their side, right? So this host project will be creating a VPC, a shared VPC. Again, it is the same concept, how the network is created otherwise in standalone. The same way we are creating the network. There is no changes in the concept. So it is creating the network in the region. Then in the region, I will have a subnet. Okay. Then it will have some internal IP addresses. Okay. Now these internal IP addresses are being shared with the resources created in a service project, right? So I have my central project. This is my central project, host project, which has the only the network created. Now the networking person who is in charge of taking care of the networks, he is going to only take the control here. We don't have to let it go and check what is happening with the service project. Only task that network person has is just ensure that it is sharing the networks whatever is created within this particular project, host project, with the service project. Okay. Now within the service project, as we discussing, we will have a compute engine instance created. That compute engine instance should have some IP addresses attached to it, right? So for that, it is going to ask or take the support from the shared VPC project network and utilize the IP address or take that network for creating its own IP addresses here, the internal IP. So in this example, you can definitely see here, you have instance A, which is here coming and taking or creating an internal IP address for itself, which is 10.0.1.3. So now this resource which is present in a separate this resource like the compute engine instance A, which is created in service project A, where there is no network created, is still accessible uh, by by the help of the network shared by the host project. Similar case for the instance B as well. So instance B is also going and connecting. It is accessible through internal IP addresses that is again shared by the shared VPC host project. Okay, and that is how that works. Now, if you see the similar scenario here for the standalone, we have already discussed now. So in this scenario, standalone one, they are not actually sharing anything with anyone else, with any other project. So in this scenario, we have a separate network created in a separate project. You are working through it. You are not sharing it with anyone. Okay. There is no central management of it. So now the network admin has to have access to this project. Okay, which is not a good practice. So that is going to create some sort of ambiguity for working or having the right set of separation of the work, right? Which is again a good concept to be aware. So separation of work should also be taken care whenever we are working with a larger project, right? So in the larger project, obviously shared VPC approach is preferred. If you have very small project, you don't need a shared VPC. You can go about without a shared VPC approach, and you can use a standalone project. Now these two instances, whenever you see they are interacting, they will have their own separate internal IPs. Okay, and they may, in standalone, it's like within the same project they are created anyway. They are able to interact with the separate IP addresses for them. Okay, here you will have a again a separate IP address, but they are coming from a separate subnets in this shared VPC approach. Is there any question on the shared VPC understanding? Is it clear or all clear?
All clear, Jitendra, from my side.
Okay, so when I say all clear, that means you did not understood anything.
Why? Because for the networking part, I have understood in the terms of sharing how it works on that.
Right.
That things
Okay.
I know. If you say everything, those who are created the Google Cloud, that person also don't know everything.
Yeah.
He is also learning.
Right. Okay. So how about Yusuf, Naresh, Vijay, Vishal? How about you? So did it make sense? What is standalone VPC and the shared VPC?
Yeah, yes, Jitendra, I could understand.
Okay. See, so as of now, also I have not gone much deeper here. Okay. We'll be going back for okay. So yeah. So for today, we are going to touch base still here. I'll try to upload this recording as soon as possible. Give me a second. Okay. So let me go back to the very first slide that we started with. Fine. So here, if you see, we just now talked about this shared VPC approach from the prod shared VPC and the dev shared VPC. Okay. So they remain same concept. There is not much difference. The way they are actually interacting, that is different. Like they will have a cloud router by default, which routes your traffic. Okay. Then there are a different connectivity options, like how you connect to these services, right? So I hope I mean, most of you have known the keyword VPN, right? Virtual private network.
Yes.
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 Yes,
Whenever you
VPN we
try to
know.
connect, yes,
VPN I know. It is a separate network, private network, which is connecting
mm-hmm.
from that local to the company network.
Right. Yes, that's the clear concept about it. So it actually secures your communication whenever you are connecting with your private networks, or you can say the company organization network and all, right? So it will not let anyone to spoof or check or hack your network. I mean, it is going to be encrypted communication. Okay, so that is about the cloud VPN. But what if you want to have the better network strength, better network connectivity, and you don't want to use any of these public IPs? Because cloud VPN is going to use the public IPs for communication. Okay, so if you want to have all this communication with just the internal IP addresses only, there will be using a dedicated interconnect. That is the another service. These are the connectivity options. How you connect to the cloud network, right? So cloud VPN is one, and there are a few more list of connectivity options. Here in this architecture, we are talking about the dedicated interconnect. There is the network peering. There is a dedicated partner connect or partner interconnect, right? So there are multiple other options that we connect with the network. Okay, how we access the resources. But on high level, let's take this understanding. So cloud VPN, which is like more of when you are doing a POC, much lesser bandwidth you require, because here you are getting like 1.5 Gbps per tunnel, and there are going to be two tunnels altogether. So 3 Gbps of transfer rate maximum you can get with cloud VPN. But dedicated interconnect will have a minimum of 10 Gbps network is transfer rate. Okay, the speed at which you are getting to access the network, right? So that is much performant, and it is through the internal IP addresses only, like the internal IP addresses that we talked about the VPC, right? So same internal IP addresses, and the on premises or other clouds I mean the network wherever you are going to communicate, that will also be using its own internal IP addresses only to connect or establish a connection and then communicate. Okay, so dedicated interconnected is for that. Okay, now there are a few more services. Like one is, if you remember, we have already have a lab done for firewall rules. It is the same concept, there is no change with it. So we have a firewall rule to set up like whether we want to allow any traffic to and from a resource, right? Then there is another service which will be covering in tomorrow's session as well, which is about cloudnet, okay, which is cloud network address translation, which is only for connecting resources without external IP addresses. Here what it means, so let me probably cover it a bit here. So cloudnet is about, you have your computer, I mean the compute engine instance you created in your environment, virtual private cloud. We had disabled the public IPs, if you recall, whenever you created the compute engine instance. Do we recall it?
Yes, Jitin.
Yeah, so we disabled the public IP addresses, right? And then we also had added a firewall rule saying that, okay, deny any access from other IP addresses like that, right? Now if we only have the internal IP addresses, but whenever there is an upgrade happening, there are some patches I want to add, I want to install some applications from the internet to the machine where I'm working without enabling any public IP address to it, right? So in that scenario, I'm actually having one-way communication. I'm only going to have egress scenario, like I'm going to go outside from the console or the network, the internal network that I'm created. I'm going to go and communicate to the external world, download my application software, and that's all. The outside resource should not be able to reach me. Okay, so it is just one-way communication I'm going to do, and for that there is a separate service called cloudnet, cloud network address translation. Okay, so it is kind of a proxy, you can say, which will filter out and try to serve the request whatever I am doing from inside the environment to the external world. Okay, so that is about the cloudnet. Then there is a another service again for managing the cloud DNS, like how the any of the URLs whenever it is hitting on I mean, like I have this console.cloud.google.com. So whenever I try to hit that, it is going to be checked with the cloud DNS service, which will have the information about the IP address of the resource I'm trying to access, right? So whenever I'm going to enter a URL, it is going to check, okay, this is the URL, this is the domain name. Now, with which IP address it is linked to, let me find it out. There are internal processes that is involved around it, but on high level, it is going to check what is the IP address. If it is nearest to my location from where I'm trying to access, okay, it is going to combine it with the cloud load balancing and all. So altogether this, the cloud DNS is going to help me identify what IP address it is asking for and try to serve that with the use of this cloud DNS service. Okay, so it is for managing your public and private DNS. Even the internal, like I want to have some sort of communication from one compute engine instance to another compute engine instance within the same network, same VPC, or there can be multiple other VPC also, right? I have created one project, and within that one network I will have another project, and in that also if I want to create a separate network, okay, I can create that, right? And that will also have some sort of IP attached to it, both of them. So suppose if I want to have the communication established with them, so for that also there should be someone who is managing it, right? Like what is the domain, like even internal IP. So here I want to add one pointer. Even the internal IP addresses, whatever you saw in this, okay, go back, and you need to make a note of it. So no, this one, right? So this internal IP address, what you are seeing here, 10.0.1.3 and 10.15.0 10.15.2.4. So these are IP addresses what you're seeing, but they will also have their internal domain name, okay, which is called FQDN, fully qualified domain name. So this I mean, they are also, this information is also stored in where cloud DNS. in this service, cloud, not net, but yeah, in cloud DNS service, that information is stored. What is the domain and what is IP address for the internal services as well. So that is being taken care or managed by the cloud DNS service. They will manage your public and private DNS. Okay. Okay. Now we have already talked about this service project and shared VPC, which is both same thing for the dev and the prod project. Okay. Now next we'll be discussing about cloud load balancing, a little more about the cloud net. Okay, in tomorrow's session, and yeah, so that would be more on very much high level on networking. Networking is very huge concept. Okay, very hard to understand in one shot. So far I have tried to cover it based on this architecture. There can be different ways of representing it. I try to touch base on what are the different tiers, the standard tier and the premium tier. Obviously they will have their own advantages and disadvantages. Okay, the services around a network. So you can have a cloud CDN, cloud armor, and cloud IAP as well. Okay, we'll have the cloud DNS, firewall rules we have already seen, cloud net, and cloud router as well. Cloud router is for routing your request, like whatever is identified or defined by cloud DNS. That information is now passed to the cloud router, which will move the request based on that, right? Okay, so that is going to be all for today's session. Let's come back tomorrow and then cover what we have left behind, like cloud load balancing, important one. Cloud net, a bit of it we need to touch base. Okay, though it is important, but not that deeper as compared to cloud load balancing, because that it makes more sense to understand how the load balancing works. Okay, fine. So let's continue tomorrow then. Yeah.